We will now be looking at ratios. But first, before we start, just a quick introduction on how to do mathematics. Now, number and copy the examples. Ask your tutor or teacher if there are any steps that you do not understand. Number the questions. Unless you have the ability to get fit while watching someone else run, you must do the questions on your own before watching the answers. Mark your work and write down the corrections. Make sure you understand where you went wrong. This will enable you to do better the next time you attempt a similar sum. Now, to get started, we start with the theory. And if we have a triangle and we name this angle theta, then from this angle, the side that's opposite this angle is our opposite side, so that's easy enough to remember. Then the side that's opposite the right angled angle is the hypotenuse side, and then the side that lies between our angle and the right angle is the adjacent side. So and now we're going to define sine theta, cosine theta, and tan theta. So the sine of theta is our opposite side's length over our hypotenuse side's length. And then the cosine of theta or cos of theta is the adjacent side over the hypotenuse side. And then the tan of theta is the opposite side's length over the adjacent side. Now, a way to remember that is to write down sine theta, cosine theta, and tan theta, and then write next to it, oh, how another hour of algebra. So if we look at an example, for example 1, we need to find the following trig ratios, and we've been given this triangle, so we're going to find sine t. Now, sine t, if I look at this, it has to be a right angle triangle, so I'm going to use TPQ. So we know that sine is equal to opposites over hypotenuse. So therefore, sine t is equal to, so from angle T, our opposite side is PQ, so that's PQ over hypotenuse. So in TPQ, the side across or opposite the right angle is PT, so that's then over PT. Then for B, tan P2, so tan is opposite over adjacent. Now P2 is over here. Now for tan, we're going to work in the smaller triangle PRQ, that's also a right angle triangle. So for opposite in this triangle, we have RQ, so tan of P2 is equal to RQ over, and then adjacent is PQ, so PQ. Then for C, cos R1, now R1 is over here, and cos is adjacent over hypotenuse. Now our adjacent angle is the angle between our applicable angle that we're working from and the right angle, so that's this RQ, so cos R1 is equal to RQ over hypotenuse across from the right angle is PR. So for question 1.1, find the following trig ratios. Now we want to find sine A in triangle ADC. So if we have triangle, this is the big triangle, ADC. So we're going to find sine A, and sine is opposite over hypotenuse, so that's equal to, from A, opposite is DC over, and hypotenuse is AD. Then B, we want to find cos of angle C2, and cos we know is adjacent over hypotenuse. So from C2, so C2 is over here, so this is this angle. That means, and we want to find it in triangle AEC. So A, E, and C, this triangle. So to start, adjacent is the EC, so that's EC over hypotenuse. So here's our right angle. So across from that is AC. So that's AC. Then C. So we want to find tan of angle D. And tan is opposite over adjacent. So if we have angle D in triangle CDE, so CDE is this smaller triangle, then to find the opposite side, that's just the opposite side EC over the adjacent side is this side from the angle to the right angle, so that's DE. Now in calculating sides or finding sides, we have example 2, and it says calculate x. So if we're working from this angle, then the angle x, or x is not the angle, the side x is going to be our adjacent side, and then over here the side that's 20 is across from the right angle, so that is the hypotenuse. Now the ratio that has adjacent and hypotenuse, if we look at our three ratios, then cos, let's say cos of theta is then equal to adjacent over hypotenuse. So we're going to use cos since its definition has adjacent and hypotenuse. Now we simply substitute our known values. So we have that cos of 45 degrees is equal to adjacent, so that's the x over 20. And then we need to just solve for x. So what I'm going to do is I'm going to think about this as cross multiplication. So I can take the 20 up, so therefore x is equal to 20 cos of 45, or 20 times cos 45 degrees. And then we just put that into the calculator. We have 20 cos 45, and that gives us 10 square root 2. So that's equal to 10 square root of 2. And then also if we want that to 2 decimal places, we'll press SD, and we have 14.14. So this is equal to 14,14. So for question 2.1, now we're working out of this angle, since this is the known angle, and from this angle, this side over here that we need to find A is actually the adjacent side, since it's between our angle and our right angle. So this is our adjacent side, and then this side, which is opposite the angle, is the opposite side. So from our trig ratios, opposite and adjacent it belongs to tan. So tan of theta is equal to opposite over adjacent. And now I just substitute my values. So tan of the angle 61 degrees is equal to opposite, which is 24,4 over adjacent. So now I need to solve for adjacent. So once again, I'm going to think about this because it's one term equal to one term and they're fractions. I can use cross multiplication. So what I'm going to do is I'm going to take the A up and I'm going to bring the tan 61 down. So this is then A equals to 24,4 over tan of 61 degrees. And then let's put that into the calculator. We have a fraction, and then 24.4 over tan 61. So this gives us 13,53. 13,53. So this is a length. Now if we ask to find an angle, when we're given two sides, over here we have our angle over here, and then from this angle, this is the opposite side and this is the adjacent side. So opposite over adjacent, once again we've got tan, so tan of theta is equal to opposite over adjacent, and then we substitute in what we have. So we have that tan of theta is equal to opposite is 3,1 over adjacent 7,6. Now if I should solve for theta, I take the inverse of tan on both sides. So this is then theta is equal to the inverse of 3,1 over 7,6, and that I just put into the calculator. So I say shift of tan, and then I have 3.1 over 7.6, and that is equal to 22,19 degrees, because we worked out the angle. Now question 3.1, calculate beta. So beta over here. Then over here we have the hypotenuse side, since it's across the right angle, and between our angle and the right angle we have the adjacent. So adjacent and hypotenuse, that is cos. So cos of beta is equal to adjacent over hypotenuse. Now substituting my known values, cos of beta is equal to adjacent is 11,5 and hypotenuse is 26,2. To solve for beta, I take the inverse of cos on both sides. So cos or beta is equal to inverse of cos 11,5 over 26,2. So this is then equal to, I have shift cos and then 11.5 over 26.2, and this is equal to 63,96 degrees.